Hi folks, it's Bill from AT Makers. Thank you for joining us this afternoon, evening, depending on where you are. We are going to follow up on our PCB project number 1 video. Hopefully y'all can hear me well. I am in the studio, in the workshop, not in the studio, so audio is never quite as good in here, but hopefully it is adequate. If not, tell me in the comments. I'll see if I can fix any problems you guys are having. We are going to do a live assembly of the boards we designed last week, which is kind of cool that we can do that in a week. I hope you guys agree. Last week we were live on YouTube and recorded on Facebook. This week we're doing the opposite. So if you know anybody who's waiting for me on YouTube, tell them to watch on Facebook, or we'll post it live there later. I would love to get to the point where I can do what Adafruit and others do, where they live stream to both. It is a bit of a star alignment thing to do that. So hopefully that's something we can do in the future. We'll see. I am trying to monitor things, watch for comments, watch for people watching, and things like that. But I only have one screen, so I'm kind of going to suck at it tonight. But we're going to do what we can, and I'll see what I can do about fixing that up for the next time. So let's kind of get started a little bit and talk about what we're working on. Now, if you guys remember, last week we designed this schematic. This is a board that is a switch isolator. If you guys remember, I think I mentioned the fact that this might not be exactly the tool that people need. It's not going to be earth moving, that this is so much better that we now have a switch isolator. The idea here is this is something simple that AT needs, that we can make with a PCB board, and that we can all assemble, and everybody can do this. Kind of everybody who's making adapted toys can probably do this too, and I'd like to teach you guys how to use it. So after we designed this schematic, we designed this board, if you guys remember. And this is basically going to have a jack on the left, which is the input, so that your switch will go over here, your device will plug in over on the other side, and it relays the signal. So if you hit your switch over here, it will actually activate the device on the right-hand side. That might sound like it's a waste of time, but by using this relay, it lets things like the candy corn, the honeybee, proximity switches, EMG switches that aren't designed to work with motorized toys like bubble blowers and model trains and anything else that's got a bigger motor or a bigger battery. It lets that work. So that's the idea. Is let's walk through something simple that everybody can do and kind of get an idea on making PCBs. So let me check on a couple things here. Make sure you guys can see this. It looks like you can. And I'm going to type. Sometimes I don't see your comments until I type one, so let me go ahead and type one. Hi, folks. And so if you're here and watching, say hi. Okay? All right, so let's go ahead and take a look. We got the boards back from PCBWay. So let me show you kind of how those look and what they look like. Here we go. All right, so let's see if I can get decent lighting for both me and it. Well, good enough. So so right here is the board we got back from PCBWay. So this came from China. It could have come from Osh Park. It could have come from any number of things, a number of places that make PCBs these days. But ours came from PCBWay in China. We ordered them last Tuesday night, right after we finished the show, and we got them this Tuesday night. So it took, this Monday around 7 p.m. So it took about 4 or 5 business days to get these. Let's see if I can kind of get this nice and clear for you guys. Yeah, it's pretty good. So this is what they look like. You've got the spot over here for your input, let me get this right, the input jack, a couple of resistors, a transistor, a spot for your diode, a spot for your relay, and then your output jack over here. And you'll notice this looks exactly like it did on the PCB layout that we saw in Eagle. On the back, there's a spot for your battery. Now, I will tell you, we made a couple of errors on this board. All of which can easily be compensated for. We can use every one of these boards. We're not shipping anything back. We're not reordering. But we did make a couple of mistakes. And I guess I did. I'm the one who did this mainly. I also found a mistake in a very small mistake in one of the parts that we used in Eagle. So I got to report that. So I'll walk you through those first before we start assembling this. But in a few minutes, we're going to put all the parts on here. You'll see, as far as the parts go, we got in a battery holder from all the parts came from DigiKey. I ordered them Monday. They got here yesterday. And the total cost is somewhere around $8 a piece in parts for every one of these boards. Okay. Hi, Dannon. Hi, Wendy. Good to see you. This is the relay that we needed. All right, so this is the relay. It's going to go on the board as well. We have two of these jacks, which are going to pop in right there. So two of those. We needed a NPN transistor. It turns out I already had one, but I ordered a bunch anyways. We need a diode. We talked last week about how we probably didn't really need the flyback diode, but we were going to use it because it's good practice. We need a resistor. There's a gate resistor that before it goes into the transistor, we need a resistor. And then it turns out I had said we needed a second resistor. We really didn't. Which is one of the mistakes I made. And so instead of that resistor, we're just going to use a piece of wire, which essentially will work as a 0 ohm resistor. And I'll explain that for you in just a second. Okay? So let's go ahead and take a look real quick at the schematic and the PCB board that we did last week in Eagle again. And I'll walk you through where the problems were and what we have to work around. Okay? All right, so let's do the schematic first because this is where I made my biggest mistake. Right here is where the problem is. So just walk through the diagram really quickly. There's a battery. Current will flow from the battery and into the relay. It will then stop at this transistor. It'll be stopped so that it can't continue unless current comes in on the left-hand side at the gate. So standard NPN transistor. So the current from the battery also goes out our jack, which goes to our switch, comes back in. And so when we hit the button, when we close this switch, it's going to allow the current to go into the gate, which allows current to flow through and lets this relay open up, which is what triggers this switch over here to close. Again, this diode is not that important, but we talked about it enough last time. This is really the error. I made a mistake. There does not need to be a resistor here at all. I should have known better. But when I last did this, I was actually using a 3-volt relay with a 5-volt source. And so I added one in, and I just remembered having it there. So I made a mistake. It's not a big deal. In the future, we'll remove this. In fact, we can do it right now. We can type in DEL for delete. We can delete that. We'll go ahead and delete this as well. I do recommend you delete the whole wire just because sometimes Eagle isn't clear about whether it deleted the wire or not. So then we'll take this and we'll run it straight back up to the battery, to the negative end. So this is the way that schematic should have looked. All we're going to do is, so essentially what we're doing is we're replacing a resistor with a wire. So we're going to, when we wire this up, we will replace one of the resistors with a wire. Not that hard, easy to fix. The other big mistake we made, so as you see when we go over to the board here, there is now an air wire right here, which is basically telling us, hey, you need to run a wire from here to there, which is exactly what we're going to do today. But for future ones, for any future ones that we make, we'll actually want to route a wire like this. All right, so that will actually let that go through. And let me actually just, before I forget, let me make that bigger. I forgot to set my default to 12 here. There we go. So that fixes the first mistake that I made last time. The second mistake is much more subtle. If you look carefully at this board, something is missing, and you wouldn't notice it here, and you wouldn't really notice it until you tried to use it, which is there are no mounting holes. There is no way for us to screw this into a board or put it into a case. Not the end of the world. I'll show you that. Actually, I can kind of show you real quickly here. Let me share this. So what I did was I actually 3D printed a case that press fits this. So this will actually snap right in here, nice and tight, like that. So that'll hold it, and that'll be fine. It's just that if you're ever really thinking about making a board, don't forget to include the mounting holes, because otherwise you have to come up with something like this. And yeah, Brady, you were there. You could have corrected me. So by all means, make sure we include a mounting hole the next time we do this. Okay, so that's the second one, and then there's the third thing, which is much smaller. It is that this battery that we used, which actually comes from the standard Eagle libraries, actually is a little bit wrong. When you actually look at the PCB, if you look at this here, I'll show you the mock-up of it here. So this is what the backside looks like. And it really looks to me like this should be the positive side of the battery, right? I hope my camera isn't in the way there. It really looks like this should be the positive end of the battery, because we think of that's what a battery looks like. But in reality, this is the positive end of the battery. And so I messed up. I misplaced it once until I realized that this is actually a problem with the part. So I'll report that. It's not a big deal, because this particular part can be flipped and put in, so that it works fine. But these are all little things that I wouldn't be surprised that anybody making a PCB board will face this kind of a problem. Okay? So let me go real quick and see if we've got any questions from you guys. Brady says clip it. I think he means how to place it into a enclosure. So hopefully Noah or Pedro Ruiz will be here. They've got tons of experience in making enclosures around things, snap fitting and things like that. The one I made actually turned out really well. I'll show you it at the end of the thing. That is not a big deal. Just in the future, putting an extra hole or two so that it's easy to screw into place is handy. Okay? All right, I see lots of smiles or something over there. I can't tell what's going on the left-hand side, so hopefully you all are happy. Okay? All right, so let's get started and go ahead and start making this. Okay? So I'm not going to use any parts here that are in any way, any tools that are in any way complicated. I have a standard soldering iron, which I probably should have already heated up, but it is an inexpensive one. It's one I actually bought, I believe, from Adafruit. If I didn't buy it from them, I do know that they sell it. So it is right here. Let me zoom out here for a second. This is a totally standard soldering iron with a fine point tip. Probably don't even need this fine pointed tip. Looks just about like that. I have a wet sponge over here for wiping things off. I'm not going to try to get that into your view, but it'll clean it off like that. I have some solder. This is leaded solder. There are people who will want to use non-leaded solder if you're in a classroom or something like that. But this is easier, and I use it. So I figure there's no point in changing something just because you guys are watching. I would normally put this in a clamp or some way to make it easier for me. But since you're watching, I'm going to work on making it easier for you, including getting you as much light as possible. All right, so I should probably show you what I do. I'm an old man, in case you don't know, with bad vision, and so I actually use one of these. Okay, so this is it's a lighted magnifying glass, and so I use it all the time when I'm soldering. I highly recommend it. It's actually got two big benefits. The first is I can see, which is huge. The second is that if I'm cutting things, I don't have to wear glasses, because things tend to pop off and hit me in the eye if I don't. So that's helpful too. So I'm not going to clamp this. I'm going to try and get this easy for you guys to see. Hopefully that works. I have a Teflon silicone pad down. It's really handy. It's not necessary because it's just plywood underneath it. but I do really like it. So there are times when it's really handy. So I'm going to assemble this by starting in the middle. So I'm going to start with these components here in the center, and then work my way out. Also, I'm going to do the smaller pieces first. The big pieces get in the way, so there's no point in having them in the way until we really need them to. So we'll do this resistor, that diode, this transistor, then we'll do this relay. This was a resistor, but we're going to go ahead and put a wire in there, and then we'll do the 2 jacks at the end. Now I'm going to leave my camera up, realize I'm not looking at you. Brady says, what was the first thing that you changed? What was the first thing that I changed? Be more clear and I'll answer your question. I'm going to start soldering things up. Okay? All right, so let's start with this resistor right here. This is a 1K resistor. And I'm just going to bend it square like this. Okay? And then we'll just wire it in. Resistors are nice and easy. They don't care which direction you put them in. So that goes in just like that. Bend these over like that. Okay? And then I'm just going to solder these in place. As always, I make sure I have a wet tip like that. This in. There and there. Okay. That looks good. The other tool I'll use a lot here is one of these. These are flush cut pliers. It's actually really important on this particular project that we use flush cut pliers because we're going to mount a battery holder right just above this, and we want these as flush as possible. Okay. All right. So there's one. There you go. So of our, I don't know, 8 components, one is done. Brady, I see that you say, what was the first thing you changed? I still don't understand your question. So, all right, so let's do the next one. That would be the diode. Diodes do care which direction that you insert them, but thankfully, the Eagle part that we used actually tells us that that would be wrong, and that we need to plug it in with the lines that line up just the way it is there. Okay. Again, we bend this square. Make sure it's going in the right direction. Nice and flush. Clean the tip. And we'll cut that off. Okay. So that's 2. Right? So we're going to do the transistor. The transistor has 3 leads. And again, thankfully, the PCB software, the Eagle software, the part tells us exactly which way to go. We're going to line up the shape of the transistor here. So make that a little brighter for you guys. Sorry. There you go. We're going to line it up to match the shape on the board. We still need to kind of bend these out a little bit. I'll show you after I bend them kind of what they look like. I can't do this underneath the camera, sorry. Alright, so they're going to look about like that. Okay, I just bent those to match that shape. They'll go in here. So much harder to do this with cameras. Whenever people say things are harder to do with cameras, just believe them. This is infinitely harder to do with a camera than without one. Okay, so I bend those back like that. Grab my soldering iron. All right. All right, so that one's in there. So now we've got the, this used to be the resistor. Let's go ahead and put this in now. This is not going to be a resistor. You can think of it as a 0 ohm resistor, a 0 resistance resistor. It's just a piece of wire, okay? It's a stripped piece of wire that's about the right length. And we'll just insert it like this. Okay? All right. Now, well, you guys can see this. Okay. Cut this one. And this one. I need to get rid of the little stems here. All right. So that's all of our small components completed. Right? And now we got to do this relay, the battery, and the 2 jacks. Let me check and see if there's any questions over here before I go on. You made a change to the schematic as I was logging in. Just curious what it was. Oh, I removed a resistor. So where this wire is right here, Brady, we had originally had a resistor that was unnecessary, so I replaced it with this wire. And so I changed it in the schematic as well. All right. So let's do the relay. So here's my relay. Oh, we have a lot of thunder here. Let's hope we don't lose power. That would kill this pretty promptly. So when you have a big piece like this, the best way to do this is to bend over 1 or 2 of the pins on the corners. That'll just make it stay where you want it. Okay? And same thing. This is, again, not rocket science. Everybody here can do this. One, and kind of got a face full of smoke there. And there is no right order here. I generally do corners first. I don't know that it really matters at all. I also generally use some kind of a clamp so it's not moving this much, but I couldn't get my clamp underneath the camera, so it is what it is. Okay, that looks pretty good. And we're gonna we are gonna go ahead and trim these. Normally I would not bother trimming these pieces, but you'll see why in a minute. It is kind of important that we keep these as short as we can. So we'll just get in here and trim them up as much as we can. Okay. All right, so the resistor's on there. All right, going back, that's the order we had it before. All right, so the only thing left are our 2 jacks here and there. These go on this side, and just like everything else, if we need them to stay in place, we can bend the tabs over. I'll go ahead and use my flush cut to just kind of bend that over. Okay. And I'll go ahead and put the second one out at the same time. I don't know how well you can see this again, sorry. Yeah, I'll do them one at a time. So I'm going to actually place something underneath this end just because I want it to, I want it to be pushed down, okay? Again, normally it'd be in a clamp, but it works. Well, these are much bigger tabs. You'll notice the holes here are much bigger. The new jacks that I'll show you later actually have much bigger ones. Make sure you fill these. The idea here is they're actually holding the physical jack in place when you shove the plug into it. So it matters a little more that they are well soldered. This isn't just an electrical connection, it's the physical connection as well. Okay. Yeah, that could be a lot better. So let me actually push this up. There we go. There we go. All right, so what I did right there was I just made sure that this was nice and flush. I don't know how well you guys could see that, but it wasn't flush. It is now, and I'll try to do better on the next one. It's just hard to do underneath these lights and cameras. Okay, let's see. Got to get a fume extractor. Seriously not healthy to breathe. Yes and no. I have a fume extractor right in front of me. It is turned off because I want you guys to be able to hear what I'm saying. I don't like the smell, but most of the fumes are actually just rosin, which is just tree sap. It's not lead. It's not going to kill me. I'm a big boy. I'm going to die of cancer when I'm 65, not smoke inhalation when I'm in my 40s, so I'm not worried about it. Okay? But thank you for your care, Brady. Here, I'll put this on here. Just trying to get a good good pressure. Meh. I'm just going to have to hold it in place this time. It would be really nice if I had something the right height. I have nothing the right height. I know, you're like, how are we going to do it if you can't find something the right height? So, my challenge here is I need to be able to prop this up, okay? Just enough to keep the pressure on it. There you go. There you go. So this is just because on the last one it didn't stay level. I just want something level there, okay? So I'll prop that up. I know I'm not talking. I'm supposed to talk all the time. Much better. Nice and flush. Okay? So all I did to make that a little easier was I propped these up. The right answer here is actually to use a clamp or like a pan of ice or something to hold this in place. But this is kind of all of the parts we talked about making, right? So we got our 0 ohm resistor or wire, our transistor, our resistor, our diode, our relay, and our 2 jacks are all assembled just fine. The only thing left to put on would be the battery holder. And as I mentioned, I learned that this is actually backwards. This should be this way. So that should go just like that. So you'll see here, you see how there's all those solder points underneath there? That's why I actually went through and cut the relay tabs as close as I could. Again, it's not a problem. It's just part of this design is double-sided surface mounts or through-hole mounts. So I put these on like this, and then I'll go ahead and solder them. Again, this is a much bigger component. It's holding a lot more weight, so I'm going to use a lot more solder on it. It's also got a bigger lead. There you go. Oh, you couldn't see that last one, sorry. Again, that's why I like the little magnifying glass. All right, so there's our whole board. There's everything, okay? Let's see. David says, gotta get a fume extractor, seriously not healthy. Oh, I thought Brady had said that. So Damon said that. So, yes, I get it. Rubber band or spring clamp. Yeah, all good ideas. It kind of works. So, this board should work. If I stick a battery in it, which I have, this should work. So let's go ahead and do that. I suppose it's a moment of truth. It might not. We'll find out, right? So this is the device side, and this is the switch side. And so I don't know if you guys can hear this. That is the relay going off when I hit this button. So it absolutely is working. When I hit this button, you can hear this relay going off, which will make this contact go off. So it does exactly what we said it was going to do. It's actually a really nice size. It kind of works. It took me, I don't know, half an hour with talking to assemble it. I bet without the camera I could probably do it in 10 minutes. It's just a ballpark. And so that's kind of the assembly. That's what it takes to put one of these things together. All this is through-hole soldering, which is where I would start with. I wouldn't go jumping into anything more complicated like surface mount. But I think everybody who has adapted a toy can do what I just did. This is again not rocket surgery, right? Let me see if I can zoom out a little bit here. First of all, any questions? I'm on the Facebook group. I'm on looking at the thing. It says, nice. It says, thank you, Brady. It says, how many cycles would you expect out of a battery? Tons. Absolutely tons. In fact, one of the questions that I think a good one that goes with that question is, should we have a switch? Right? So one of the questions is, so when this thing is not connected, is this burning any juice? Right? Let me see if I can get this a little better here. So there you go. So when this is not connected to a switch, or when a switch is connected but nobody's hitting the button, is it killing our battery at all? So I went ahead and did a test, and the answer is it's not even measurable. Not even like a microamp. Nothing. I'm sure there is a tiny amount of current that runs through the transistor at all times. But it is not drawing any significant amperage when we're not using it. Now, it is a non-latching relay, which means that as long as I hold this down, that relay is closed, and it is burning juice. So how many presses would it take? I guess what I would need to do would get, how long is a press? Let's say it's, I don't know, a quarter second? Probably depend, maybe a half second. If you'd like, what I will do is I will set up I'll set one of these up with the switch down and tell you how many hours it lasts. How about that? Or at least within some estimate. I'll probably check it every hour and see when it dies. So I can do that for you, and then you can probably divide that out to the number of clicks that would go into that. Hopefully that'll give you a good enough answer. I would say thousands, certainly hundreds, but I would say thousands. This isn't a coin cell, right? So this is a AAA battery. We can calculate the milliamp hours in the battery. Somebody out there probably knows. But this is using very little current, right? So this is a 1.5 volt. It's a 1.5 volt relay that needs 30 milliamps to activate it. So you can probably do some math. Brady, you're just the guy to do it if you want to tell me how many amps it takes to activate that. Brady says, what would be the cost to add an LED indicator for when the relay is closed? Probably 50 cents. Now that we don't have this resistor, there's actually enough room here for one. Again, you're going to do through hole, and you will need another resistor. So you'll have to add a resistor and a through hole LED indicator. But you can certainly do that by all means, and then you'd have a indicator. It's very easy for me to tell when it's on because I can hear it, just like I can hear the thunder. But it's probably not as easy for you guys. Let me see if I can kind of show you. Anyway, it's very clear when you're here to know when it's activated. I could certainly plug in something to this end and show that it's working as well. Okay. All right. So this is actually a large part of the battle. If you remember, one of the motivators for this was actually that I had a guy from an AT company once say, "You're never going to sell that as long as it's inside of a Altoids tin." And he wasn't wrong, but I wasn't trying to sell it. I was trying to give it away. So I thought I'd go ahead and finish the project and show that we can actually make this look pretty darn professional, right? So I made a case that exactly fits this. Okay, let me switch back to the overhead. So I made a case. It is 3D printed. It's about the size of a battery charger kind of thing. It has its flaws. It's not perfect. I would do another iteration. This is my second print of this, not my first. My first was not. My first was less perfect than this. This is still imperfect, but it's pretty darn good. So this should fit just like that, and it should actually snap right in there, and it does. And so then I snap this one on top, and with any luck, it should. Oh, it needs to press all the way in there. There we go. It should screw down fairly tight. It will not be perfect. This might be loud. I'm sorry. I'm going to use a drill. I'm not going to do this by hand. All right, so this could be a little bit better. Could probably use 2 more screws, but this is kind of okay, right? It tells me which side the device is, which side the switch is, and if I plug my switch in, where is it? There you go. Plug my switch in. That's working like a champ, right? So this is product-ish. It's got a big D for the device side, and it's got a big S for the switch side. I'm not sure why you guys can see that. And overall, this is kind of solid. If you'd like, I can show you how to make the case. Let me open up Fusion. That'll take a minute. But so we can make a product that is essentially, it is as good as many things I've seen sold for AT. And so let's talk about total cost. The PCB board was $2.70. The relay is about $2. Each of the jacks is about 80 cents. And the resistors and the diodes and the transistors are like $0.25 a piece or so. So, I mean, Brady, if you want to do a bill of materials for me, that'd be great. But I'd say $10 with the filament is probably about where we are. It's about $10 to make this. That would make it a $25 to $30 product if you're actually selling it. And it's really useful. I think that if you talk to Julie Marzano, she probably has people who can't use their candy corn or honeybee switches with the first things they want to work with on it. So if they want to have a honeybee switch that controls a train or a toy, a bubble blower, it's not going to work. It's not going to work with a candy corn. I guess I should probably plug in a candy corn. I have one here, and make sure that it can activate the relay, because that's actually the use case. So let's make sure that works. And turn this little switch on. And so, yeah, it works like a champ. So whenever this goes on, I can hear it clicking there. So it basically allows your candy corn or honeybee to be able to activate anything, right? Any reasonable voltage that will plug into this side. Okay. So let's show how we would make the case for it. Go back to my screen. Before we do, let me check for any questions. Hi, Eric. Any contacts at EnableNet? I think you mean AbleNet. Maybe you should pitch it as an add-on sale when candy corn switches are purchased. I have done that. I don't think they were interested. They can make their own. There's no reason they can't make one of these. If there was enough demand, I'm sure they would sell them. I think. I like making them anyway, so I'm good with it. Okay. There isn't an Enable Mart. I don't think you mean Enable Mart. I think you mean AbleNet, who makes the candy corn. So, but let's go through this. Let's talk about how to make the actual case. Hopefully, Noah and Pedro Ruiz at some point come on. They are way better at making cases than I am. But I will show you how I went ahead and made it. This is the case I just showed you in Fusion 360, which is a Autodesk product. You'll see it looks just about exactly like the one you just saw me put together. I probably could indent these a little farther. They're not that easy to read on camera. They're much easier to read in person. I'm not sure why that is. But let's go ahead and show how to make this. So we started in Eagle. So we actually were here. And what I did first was I used Fusion Sync, which is an add-on. It's a free thing, free, included in the cost of Eagle, which is free for makers. Okay, it's very expensive if you're a company doing this. And I hit Create New Fusion Design. I'm not going to go through that because it takes about 5 minutes. But what it does is it comes up and makes you a design that looks like this. Okay. Actually, the way it looks when you first come in is it doesn't have these, okay? So it looks just like this when you start, okay? It is just this board. So it takes our design file and it exactly exports the footprint of it into the 3D CAD software. Now, it didn't get the heights of these components right, especially including this big battery on the back. So I needed to guess, because I didn't have the components yet, and I guessed reasonable values for these and basically just added on top of them little spaces where I figured the resistors would go, where the relay would go, where the jacks would go, and where the battery would go. And in all cases, the first time I did it, I was a little bit short. I should have actually extended these out a little farther. My advice would be to always add a little bit more clearance than you think you need. Once that existed, and once I had that into Fusion 360, I realized that I didn't have the mounting holes. So that's when I really went, I have no idea how I'm going to screw these down. So I knew I had to actually have something that held this around the edge. And there is a nice little two areas here where I could put a cross beam to kind of hold it in place. So I started making the body, the top and the bottom. And I guess the best way to do this is to go ahead and walk you through from the very beginning. So there's the original PCB board. One of the nice things about Fusion is you can go back in time and show your design. You can actually make a change and it will propagate them all forward. But so that's the original design they gave me. I put the bigger bodies on top. And then I created a new, let me go back one. I created a new bottom and I made a sketch. And you'll see this sketch right here basically started with the shape of the board. It added holes for where the screws were going to go. Two of these ended up being pegs, and two of them are screws. So I made this sketch. Then I extruded that. This will be for the bottom. Okay. And then really all I had to do after that was kind of round some corners. Let me turn off the PCB board so you can see. I'm notching in here in the inside. And I'm just pushing out things to make enough room. And that's pretty much the top. Okay? I know that I just cheated because I'm not really doing these things now. I'm just talking about them. But that would be that's the bottom. Starting on the top, I'm doing the same thing. I start with a sketch, which is this sketch. It's very similar to the one that I used for the bottom, except it only has two screw holes. And I added these two bars, which are going to hold the board in place. I basically made a space for it. Let me show you it from the bottom here, so there you can see it better. So there's where the top's going to look like. I added that's what it's going to sit on, so the board's going to sit on that thing there. And then I cut the holes for the end pieces where the jacks are going to go. And then all I really did after that was, let me turn everything on so you can see this. All I really did after that was add the wording. And I just rounded a lot of corners. So if you watch, it's me adding the words here and there. I'm going to add a D and an S on the ends. And then all I really do is add lots of fillets and chamfers to kind of round off all the edges. And so there it is at the end. And so that's the box. Now, it's really cheating when I play that forward because it erased all my mistakes, right? So it took me two prints to get it where it is now. I have not actually printed it with these little holes here. This was the last mistake I made, is that if you think about how that board is made, the solder points for the battery cut into this. So I needed to make little holes there. I drilled it out on the one we just used. The next time I printed, those holes will already be there. So then from here, you just hit make, 3D print, click on this, and it will actually bring it up in Simplify 3D. Let me get rid of these two. So this is the one I just told it to print. Let me flip it. Okay. So this is what it's going to make. And if I hit prepare to print, it will actually show exactly how it's going to print this. And then I hit send to printer, and it'll go to the printer and print out. So that's how I made the cases. At this point, making the cases is probably the easiest part of this for me. So I've done a lot of those. So let's see. Brady says, do the jacks have panel mount threads on the ends? They don't. The jacks do not have panel mount threads on the end. Let me see if I can find you. Let's see here. Oh, of course, I just screwed it in. Well, here, I got them over here. The short answer here is no, Brady. So, because these are meant to be soldered onto a board, they do not have threads here. I have seen some that do, but honestly, you'd have to get them to align so perfectly. I don't think it's that useful. I do have some things to talk to you about jacks, though. To everybody about jacks. I've had quite a week of jack issues. So let's talk a little bit about what I get out of this PCB stuff and what I see that I'm learning from it. Let me get a good picture of that jack for you. There you go. So there it is. It's not very clear, is it? There you go. So I'm actually really irritated with our jacks. And let me walk you through kind of what. So I'm open to any questions, but I'm gonna get off on a little side discussion here for a minute. So we use these, hold on, these gold jacks. So we use a lot of these, right? A lot of these jacks right here. And these are panel mount jacks. I've got whole guides on how to wire these up in mono. Right, you guys probably are familiar with these. I am becoming disenchanted with them. So I've actually had a couple of them fail recently. They seem to be the ones I get from Adafruit seem to do better. The ones I get from Amazon seem to be less consistent. Let's put it that way. And what ends up happening is that right here between this metal crimp and this black piece, it's been separating when I plug in the plug. They pop loose. And I found that it happens when I tighten them by holding this with a pair of pliers and turning the nut with a nut driver or whatever I've got. And I've had a bunch of them fail. And so I'm kind of irritated with them. So much so the main thing that I've been working on that shows this, let me switch views here for a second. So the thing I've been working on the most recently is this, which is, let me get a better view. It's probably good enough. So this is Jim Fulton's switch router. So if you take a look, this is the switchboard that we had made over in at PCBWay, and this is way better than the way I had this wired when I went out to Seattle to give it to him the first time. All of the wiring that controls how the signals go from the microcontroller to the relays are on this board. But, and I hate the fact that there's a but at all in this, given how much work there's been on this, but there's still all of this wiring between the jacks and the board. And while I had absolutely no problem with the ones that I soldered down like this, I was using screw terminals, and I had several screw terminals fail. And then afterwards I had 2 of these jacks. Now this one has 8 jacks on it, right? So 2 of the 8 jacks actually failed on me, and it kind of got me grumpy. You can see one right here. Let me see if I can show you this. You can see this one actually has separated, and I can pull this like that. See that? So this thing is basically, when you put in the plug, it's been popping this out the back. Now, is this the end of the world? No, I can put it back in there. I can re-crimp it down, right? And it's fine. But it's gonna fail. And I am not sending Jim Lubin any more boards that are gonna fail. Okay, I've done enough of that. The poor guy has been waiting for this to work well since I first designed it, and I am not going to send him these. So I kind of had 2 other approaches, and I wanted to chase them both. The first is I went ahead and spent a little bit of extra money, and I got a different set of jacks. So I went to DigiKey instead of Amazon, and I got these, which, let me show you these. Exceptionally well packed. They're about, I think they're $1.80 a piece with the washer and the nut. And the thing is, that doesn't sound like a lot of money until you need 8 of them, right? And then all of a sudden the price of your product has gone up. These are all metal. They are already mono, so we don't have to do any weird wiring to make them mono, right? And I'm going to try these. They'll fit in the same holes. They're just more solid than the ones that I've been using. So I'm going to rewire the board using these, okay? And I think it'll be fine. I wasn't sure whether that was going to work, so I thought, well, I keep telling everybody on the teach them how to fish videos, or whatever Brady calls it. I keep talking about the fact that stop wiring and start getting PCB boards, right? I mean, is there any way that I can just completely get rid of the wires? right? So the idea here was, let's get rid of all this wiring, right? Let's not have to do any of it. Let's not have to do any of this wiring because it's really likely to break. So I thought I'd try that. And so at the same time I ordered those jacks, I also designed another PCB board because, you know, what else do I have to do? And so I designed this board. And this board is super cool. So let me take it apart here and kind of show you what this is. Okay? So this is a board I designed last week. Now, you might notice right off the back that something less flexible is here. When you look at the switchboard, it's very flexible, right? You've got 5 relays. You can wire them up however you want. You can jumper from one to the next. You can make this a 1x6 board or a 2x3 board or a 2x5, a 5x2 board. There's all sorts of different ways you can wire this board up, right? So this pops off. Come here. So this pops off, and this is the board that we had made by PCBWay. And it's incredibly flexible, and we love it. And I like it just the way that it is. It takes the Adafruit feather on top, and it works like a charm. But you still have a lot of wiring to do. So is there a way that I can save all that wiring if it's something I know I'm going to make a lot of? And honestly, I think I'm going to make a lot of switch routers. I think anybody who uses SIP and PUF is going to want a 2x3 switch router. I think anybody who uses just a single switch is going to want a 1x6 switch router like Gary does. So is there a way to just eliminate the wiring? And so I designed this one. And I can show you it in Eagle. It's got its flaws, but it's pretty darn good. Because what it does is it puts 8 jacks right here on the board. So these are all wired in directly, right? There's no wires in this whatsoever. Now, it is specific to using it as a 2x3 switch router. But if I pop this on here, right? If I pop this on carefully, like this, and push this down, there you go, right? So yes, it's a sandwich. I get that it's a sandwich, but there's no wires. And it's got the speaker that sounds the tone. It's got the 2 input jacks left and right. It's got the 3 outputs for the left, the 3 outputs for the right, and no wires. And I really like this. I really like this. Now, was it easy to assemble? No. Sort of. I don't know. Jim's laughing at me about not sending him any more broken stuff. So it works. Okay. Now I have some more testing to do on it, but it works, and I'm kind of thrilled about it. So I think I'm learning my own lesson as well, which is if the goal is let's get rid of the errors on the things that we're making, let's get rid of the wires. It's cost. So the most important thing to me, the lesson learned here is I don't bother trying to. I don't worry about the cost of trying this. So what is the total cost of trying this? Well, I've got lots of these headers, so let's not count those. I've got stacks of them. Each one probably cost me a penny. Okay, so every one of these jacks cost me 80 cents, but I was going to buy jacks to replace the other one, right? So I just changed the type of jack. I guess I would have thrown them away if I didn't use them. So there's, I don't know, $5 or something there. And then there's the time associated with making the board, sending it off to PCBWay, and $2.70 for the board, right? That's worth doing. That took me, that was worth doing. When I actually have to solder it, there's a lot of solder points here, right? I mean, you've got, let's count them, 1, 2, 3, 4, 5 times 6 is 30, 32, plus 12, that's 44, that's 60, another 8, 68. Every one of these is 5, so that's 1, 2, 3, 4, 5, 6, 7, 8. another 40, it's 108, 110. It's 110 solder points to make this board, and that's crazy, right? But it's so simple because all you're doing is bringing in your solder, and you're doing, 1, 2, 3, 4, 5, 6, 7. It's fast. Okay, I assembled this in about 20 minutes, and it was the first one I did. And if I wasn't being so dumb when we made this, we could have made it a lot easier. Specifically, and this, I hope you're watching, John. I'm not blaming you because we never talked about this, but we made a mistake. John and I made a mistake when we laid this out. In the gap we put between each of the relay headers is actually half of a standard peg. So I can't just put one long header here and cut out a pin. I actually have to cut these and file them down and make them fit. That's a really simple thing to fix. And if we fixed it, I bet I could assemble one of these in 10 minutes, maybe 15 minutes. And it will last forever. And I'm really sure it's not going to break on the way to Jim's house. And TSA can't break it like they did the one that I brought him in person. It's going to work. So I am really happy with how these are turning out. And I do highly recommend that you guys take a stab the next time you have a project and you're looking at some of this. All right. Dannon says it's pretty cool and neat. 80 cents per jack seems expensive to me. It is expensive. If you buy them in quantities more than 10, that price goes down, certainly. I mean, we can... it probably wouldn't hurt for us to spend a little bit of time looking at buying components and buying things on DigiKey and places like that. If you guys would like to, I'd be happy to do that. Let me push this back down so that it's working again. There we go. There we go. So Rev 2. Yeah, Rev 2, exactly. Rev 2, where there will absolutely be a Rev 1. That's why on the back of the switchboard it actually says version 1.0. We know right there that there's going to be a 2.0, no doubt about it. But this is really cool. So both of these projects have turned out great. Dannon, if you'd like to, I'll be happy to do this offline with you if you'd like to do some pricing on Jackson stuff. But basically, I use whenever I can, I use DigiKey or Adafruit. When I bought the stuff through PCBWay, they actually used a variety of vendors: Mouser, Arrow, DigiKey, a couple others. And probably got better prices because they shopped around. I know that there's actually a company that I worked for here in town in Clearwater called America 2, which is a weird name, but they are a distributor that finds the best deals for components. We should probably see if we can't partner with them and see if they can't get some either donations or good prices on stuff for us. So certainly I would like to get that down from the 80 cents, but it is what it is, and I am tired of buying them from Amazon because what happens is you end up getting a bag where everything's perfect, and the next one half of them break. Whereas I know if I'm buying these things from DigiKey or Mouser or one of the other big houses, they're going to work reliably. Okay. All right. Let's see if we have any other things here. So I'm sorry, I forgot to mention that I usually scrounge for parts from old stuff, so I rarely pay for components. Right. True, and I do some of that too. For example, I will tell you that I never buy resistors or basic components. I buy like these boxes of 10,000 resistors, all pre-packaged and labeled, so that I don't have to read all the color codes. We kind of all do some stuff like that, but whenever I make something for display or for AT makers, I make sure I tell people what it would cost them if they were buying everything new, and if they went and bought the same stuff that I'm using, right? So I want it to be reproducible. So, All right. Any questions from anybody? Good plan. Yeah. All right. So I think we are probably good. So I was going to do one more of these PCB discussions, but I might do two. So one that I want to do is I want to go through on the next one. Let me kind of show you. So I've talked about how to design a board. I've talked about how to get it sourced offshore and get it back within a week. And I've talked about kind of that process, how to do the assembly. This one was different. This is one where John and I knew, excuse me, I knew that I did not have the skills necessary to assemble this board. I think John probably does, but I think he would probably agree with me now that if we're making more than a couple, it's not worth doing that. That's not the right way to get these made. The reason it's so hard is that like these relays here, while they look just like the one we put on, they don't go all the way through the board, right? They're actually surface mount. We can probably surface mount solder these without any real problem. The real problem comes down here, right? And here. These are tiny. I don't think you guys, let me put it this way. Let me show you what a pencil lead looks like next to them, okay? So they are significantly thinner than a pencil lead. And yes, I can teach myself how to do that once. I can learn to drag solder. I know I'm not supposed to be scared of surface mount. I do get it. In fact, I have a hot air station, a rework station. I should be able to do this. But if I'm going to make a dozen of these, if I'm going to make 5 of these, that's crazy. It's going to take me way too long to do it. So what we did was we actually went through PCBWay's assembly process. So rather than just having them make the board, and they made us boards. In fact, I have here. I have one right here. So they made us boards so we could make them ourselves and practice and see if we were going to be able to do this. But we also paid them to assemble them. So they sourced the products, they sourced the parts, they verified it with us, and they made these and they shipped them back to us. So I'd like to do a video that walks through that process. It'll be less hands-on. It won't be as do-it-yourself-ish, but it's probably worth going through that process once and showing what we did and what we learned from it, because I think we learned a lot. I might ask John to, or maybe Eric from PCBWay, if they'd like to come on and do that with me, maybe, because I'm not the only one who did that, right? John did lots of it, and we had the folks from DigiKey doing a lot of it as well. So I'd like to, the total cost, including the parts. So if you look at the cost of these, every one of these relays is going to be at least a couple dollars. So that's $10, maybe $12 in relays. Another two, so 14, 16, 18, $19 in parts or so. $18 to $19 in parts or so. Maybe another buck over there. So let's say just under $20 for us to buy the parts and the PCB boards. And they made them for us for just over $30. So including the parts and the labor. So it costs us about an extra $10 a board, maybe $11 a board to have them made completely. Was it worth it? Yes. We couldn't have done this reliably. We couldn't have gotten, 15 of them cranked out in about a week and a half. Maybe 2 weeks after we got the BOM and everything done. We never could have done them ourselves that quickly. Is it important for AT to know about it? Yep. I think it's probably worth us walking through that process. So if you're all interested, I will try that for our next one. I'll walk through how we did that. I would also love it if folks from Adafruit or SparkFun or OshPark or any other maker groups want to tell me things that we did wrong or things we could have done better. I'm sure we were not ideal in our process at all. They did come back perfect, though. The number, so we had a problem with our design that was this this used to have a LED right here, and I needed to remove it. That was ours, completely ours. Once I removed this and got my test set up well, we haven't had any that failed. We haven't had any that failed when we received them, given the test that once we removed this, which was a design problem. Basically, this had no resistor on it, and it was drawing more than it should have, we think. And John may come up with other answers to that. But right now, all the boards we've gotten have worked reliably. So it's probably worth going through how we did that and how it turned out. All right. Where did you get that from? Very true, reproducible is important. I got it from digikey.com. The resistor pack. Got the resistor pack when I set up the workshop. I think I got it from Amazon. I know I just said I wasn't going to buy anything from Amazon anymore. It's not really true that I'm not going to buy from Amazon. I'm going to buy lots of things from Amazon. But I think I got it from... I have the name. Hold on. So, cause I bought it from the same place I bought the capacitor box here. Yeah. So here's the same brand, except for this one still has the label on it. It says Joe Knows Electronics. And so this one's got ceramic capacitors, electrolytic capacitors, and things like that. So same thing, organized and labeled so that you don't have to be able to tell the codes. So when I bought this, I bought a box of inductors, a box of resistors, a box of semiconductors, which included diodes, transistors, a bunch of other stuff, and then the resistors. So I bought all of those when I set up the workshop, and I'm really glad I did, because I always have them. But these jacks, I am going to start spending more money on, because I think it's important. Okay. All right, I think we're good. So any other questions, ask them below, and I'll be happy to answer them afterwards. I see them all later. And I hope you guys are getting something out of this and think it's reasonably interesting. And if not, tell me, and I will stop. All right, you guys all have a great evening, and I will talk to you later.